Guys, please confirm to me. All of you read my voice on screen. Those are attending in online. Guys, please confirm to me. All of you read my voice on screen. Those are attending in online. Am I audible? Guys, please respond to me. All of you read my voice on screen. Those are attending in online. Am I audible? Am I audible, guys? Please respond to me. All of you read my voice on screen. Those are attending in online. Please respond to me. All of you get my voice on screen, guys. Please confirm to me. Kimba, overdose. Guys, please confirm to me. All of you read my voice on screen. Those who are attending in online, please confirm to me. Am I audible? Guys, please write in questions box. All of you read my voice on screen. Those who are attending in online. Respond to me, guys. All of you read my voice on screen. Those who are attending in online. All right, sir. And check it what we completed there in the last session. I think so we are discussing about the differences between Java and other programming languages. The differences between Java and other programming languages. Third difference we have completed in the last class. In the third difference, what points can we understood there? First of all, the point is C and C++ are platform dependent programming languages, but Java is a platform independent programming language. Okay. The point is what? If any programming language allows its applications to perform compilation and execution on the same operating system, not on different operating systems, then that programming language is called platform dependent programming language. C and C++ are the examples for platform dependent programming languages. Here the point is what? If you compile C program on Windows operating system, automatically .exe file will be generated. When .exe file is generated, the .exe file nature is what? .exe file contains directly executable code and it has the local operating system representations like Windows representations. Okay, that Windows represented .exe file will be executed under Windows operating system only, not on other operating systems. So it is mandatory to provide that same Windows operating system for the execution of what their Windows represented .exe file. So their dependency is available. Because of this dependency, we can conclude that C and C++ are what? Platform dependent programming languages. Leave it. Next one is, what is this platform independent programming language? If any programming language allows its applications to perform compilation on one operating system and the execution is in another operating system, then that programming language is called platform independent programming language. Compilation and execution both are on two different operating systems. Compilation and execution both are on two different operating systems, not on the same operating system. If it is possible, then that programming language is called platform independent programming language. Then I given some diagrammatic representation yesterday. Java is the best example. Java, Python, .NET, all these are platform independent programming languages. If we take Java, if we compile Java program on Windows operating system, automatically here we are getting what? .class file. There we are getting what files there? .class file. Understand it clearly? What is the nature of the .class file? Dot class file contains bytecode. It is not directly executable code. It is an intermediate code and does not include the local operating system representations, including Windows operating system representations. It doesn't have any operating system representations, including Windows. Okay, fine. But if you want to execute this dot class file on Linux operating system, the dot class file must have the Linux representations. If you want to execute this dot class file on Solaris, it must have the Solaris representations. If you want to execute this dot class file on Mac operating system, it must have the Mac representations. Similarly, if you want to execute the dot class file on Windows operating system, the dot class file must have Windows representations. But now, as of now, we are having only what representations here? Neutral representation. It is not having any operating system representation. But to execute this bytecode, we need to have local operating system representations. Exactly in this particular situation, to make Java as a platform independent programming language, to run our Java program in multiple operating systems, Sun Microsystems has provided some converters. What that converters are able to do now? That converter, for example, here in all the four systems, we are providing four converters. The first converter is able to take that neutral bytecode as an input, and it is able to convert that neutral bytecode into local operating system representation, that is Linux representation. So this code is called what? Their native code. When we are getting this native code, if we give this native code to the execution process, then it will execute that native code and it is able to provide some output. Similarly, what is the job of this converter? The second converter, it will take the neutral bytecode as an input. It will convert that neutral bytecode into Solaris representations. That Solaris represented bytecode is called as what? Their native code. If we give this native code to the execution process, then execution process will execute that code and provide some output. Similarly, this converter is able to convert the neutral bytecode into the native code, that is Mac representations. If we give that Mac representation to this execution process, then automatically it will execute it, then it is able to provide some output. Now similarly, here this converter is able to take neutral bytecode, converting that neutral bytecode into the Windows representations, that is what their native code. That native code, if you give to the execution process, then it will provide what their some output. So this is exactly the mechanism what we are having clearly. Now in this overall process here, conversion and execution both are provided by JVM in a separate mission. Conversion and execution both are provided by Sun Microsystems in a separate mission, in a separate component. The component is what? Their JVM, Java Virtual Machine. All right. Now here I have given some questions to you. What are the various questions here? Java is a platform independent programming language because of JVMs only. Java is platform independent programming language because of JVMs only. But JVM is what? Their platform dependent. Not only JVM, the total Java software is what? Their platform dependent. Java software is not any other one. It's a combination of the Java tools. What are the various Java tools now? Java compiler, JVM, Java profiler, Java documentator, and so on and so on. So many tools are available. Nearly 30 to 35 tools. Combination is nothing but what? Their Java software. So Java is a platform independent programming language. Java is a platform independent programming language because of JVMs only. But JVM is what? Their platform dependent tutorial. Right. This is what actually the point here we are understanding. Now I need to give some description about this particular point. Now try to understand it clearly. What would be the description here I am providing there? Now try to observe carefully. Now, if we compile Java program in Windows operating system, if we compile Java program in a Windows operating system, then the compiler will generate a dot class file. Then the compiler will generate a dot class file. where the dot class file contains bytecode. It is not directly executable code. It is an intermediate code. It is what there? An intermediate code. And it does not include any operating system representations, including Windows. And if a compile a Java program in Windows operating system, then the compiler will generate a dot class file where the dot class file contains bytecode. It is not directly executable code. It is an intermediate code, and it does not include any operating system representations, including Windows. Okay, fine. Now, in this context, in the above context, to execute bytecode in any operating system, that bytecode must have the local operating system representations. That bytecode must have what their local operating system representations. In the above context, to execute bytecode in any operating system, that bytecode must have the local operating system representations. That is called native code. That is called what their native code. Fine. Right, sir. Then what next one here? I'm telling that in the above context, to execute bytecode in any operating system, that bytecode must have the local operating system representations. That is called native code. Right. To make Java as a platform independent programming language, Sun Microsystems has provided a converter to convert the program from bytecode to Sun Microsystems has provided a converter to convert the program from bytecode to the native code. How Sun Microsystems has provided these converters? Sun Microsystems, how it has provided that converters there. Sun Microsystems has provided the required conversion and execution in a single component called JVM. That is what their Java Virtual Machine, JVM, Java Virtual Machine. Now the conclusion here I am telling to you, observe carefully. Java is a platform independent programming language because of JVMs, but JVM is a platform dependent component. JVM is a platform dependent component. Note I am telling here. Alright, so Java is a platform dependent component. Then what is the node type of point here I am telling you? The node is what there? Not only JVM, the complete Java software is a platform dependent. The complete Java software is what there? Platform dependent. Right, sir. Now these are the various conclusions here we are able to understand. Anyway, here overall, interviewer will ask a question now. Java is platform dependent or platform independent? That is the question here. Answer for this question is what there? Java is what there? Platform independent. There we can say that because of JVMs only. Immediately interviewer may ask one more question. What about the JVM? JVM is platform dependent or platform independent? There we have to understand JVM is what there platform dependent. Not only JVM, the total Java software is what there platform dependent. This is exactly the points here what we understood from this total discussion. That's okay. Leave it. After this, we have one important interview question now. Try to answer for it. That interview question would be like what there. What are the differences between dot exe file and a dot class file? What are the differences between dot exe file and a dot class file? This is the question here we are getting. What are the differences between dot exe file and a dot class file? Clear? All right, sir. Now, observe carefully. Dot exe file and a dot class file. Differences if you understand. First one is dot exe file exists in C and C++. Am I right? Dot exe files are available in where? C and C++. Whereas dot class files exist in Java. Point number one. Where they're available, that information I set you. What .exe file contains and what .class files contains. .exe files contains bytecode, directly executable code. .exe files contain directly executable code, whereas .class files contain bytecode. It is not directly executable code. It is not directly executable code, and it is an intermediate code. And it is what there? An intermediate code. Also carefully. .exe file contains directly executable code, but .class file contains bytecode. It is not directly executable code, and it is an intermediate code. After this, third point here I'm telling that. Observe carefully. .exe file contains a platform dependent code. .exe file contains what there? Platform dependent code. As you already aware about it. It represents local operating system content. So .exe file is what their platform dependent. But whereas .class file is what their platform independent. It has the neutral bytecode. It is not representing any of the operating system representations. So now .exe file is a platform dependent file. .exe file is what their platform dependent file, whereas .class file is a platform independent file. This is one point. Then one more point. That point is somewhat related with the security. Try to understand it now. .exe files are able to provide lesser security. .exe files are able to provide what security? Lesser security. Whereas .class files are able to provide more security. In two ways we can conclude this point here regarding the security. What are the two ways to conclude this particular point now? In general, C and C++ are less secure programming languages. Java is what they're more secure programming language by nature. These two programming languages are available like this. So obviously .exe files are providing less security. .class files are providing more security. This is normal. But one more point is available internally. What is that point here? In general, in general, majority of the viruses related softwares are provided in the form of .exe files. In general, viruses related things are coming in the form of what they .exe files. But no virus related file is available in the form of .class files. .class files are not, that means viruses are not available in the form of what they .class files. But majority of the viruses are coming in the form of like what their .exe file. Even in this direction also, we can conclude that .exe files are able to provide less security. .class files are able to provide what their more security. That's it. Overall, these are the differences here we can identify. The first one is what there. .exe files exist in C and C++. .class files exist in Java. .exe files contain directly executable code. .class file contain bytecode. It is not directly executable code and it is an intermediate code. .exe file is a platform dependent file. .class file is a platform independent file. .exe files are able to provide less security. .class files are able to provide what there more security. These are overall the differences between .exe file and .class file. Leave this one. After this, after completion of this total content here, the next difference here we have to understand. What would be the next difference here? We are going to understand there. Observe carefully. Fourth point in the sense, the third difference is what there C and C++ are platform dependent programming languages, but Java is a platform independent programming language that we understood actually. Okay. Now the next point, fourth point here, what I am telling to you. Fourth point, pointers are existed in C and C++, but pointers are not existed in a Java. Pointers related thing, no? Pointers are existed in C and C++, but pointers are not existed in a Java. Okay. What is the meaning of this pointer? What you are thinking about the pointer here? We can understand it clearly. Okay. Window close. Cut an edge over. Right, sir. So what is this pointer here? What is the meaning of this pointer? First of all, we have to understand. After completion of that, whether pointers are available or not available, that we are going to understand clearly. Okay. First of all, what is this pointer now? What you are thinking about the pointer? What we understood the pointer. Right. See this point here. Now tell me, in general, data will be represented in the form of the variables, normal variables. Variables are able to represent data. Variables are able to represent what their data. Got it or not? But different types of variables are available. What variables are available here? Pointer variables are available. That pointer variables are able to represent Avi, light. Right. Pointer variables is one type of the variable. It is able to, pointer variable is one type of variable. It is able to store directly address locations of the data. In general, variables are able to store data, but pointer variables are not storing data. Pointer variables are able to store what their address locations of the data. Understand my point? Pointer variables are able to store what their address locations of the data. Right. Now understand it clearly. Pointer is a variable. It is able to store address locations of the data structures. Address locations of what are their data structures. Everybody understand it clearly. Pointer is a variable. It is able to store address locations of the data structures. Where what is this data structure actually? What are the various data structures now? Where the data structures may be, where data structures may be a variable, normal variable, comma, an array. Understand it now? It may be a normal variable or maybe an array. Then apart from this array, then what next one here? Maybe an array. Next one is a structure. In a C programming language, structures are available. It may be a structure or it may be another pointer variable. It may be what there? Another pointer variable. That's it. That is the meaning of like what there pointer. Understand it clearly? Pointer is a variable. It is able to store address locations of the data structures. Where the data structures may be a variable, an array, a structure, or another pointer variable. See this one. I want to show one simple representation. Try to understand it clearly. All of you observe carefully. For example, I want to take int a is equal to 50, for example, variable, normal variable. A is a variable, its data is what there, 50. Int star p, the p is a pointer variable, that is marked with a star. Star represents what there, pointer variable. Star p is a pointer variable. P is equal to ampersand a. That means ampersand a is nothing but what there, address location of the a. That address location of the a we assign to what variable, p variable. P is equal to ampersand a, address location of a. Got it? Next one is, and so on, some other code is available, it's okay. This is sufficient. So what is going to be happen here when we execute this program? When we compile this program, even not to execute this program, when we compile this program, what is going to be happen there? When compiler encounter this, when compiler compiles this instruction into a is equal to 50, directly a variable, okay, directly a variable will have 2 bytes of memory. Why sir, why we are having 2 bytes of memory? We know already this point here. In C and C++, integer variables will take 2 bytes of memory. Now here a variable will have 2 bytes of memory, where the data is what there, 50. 50 is the data here we provided. Okay, when this memory is allocated for a variable, automatically its starting address location will be created. What is the starting address location of this a? For example, 1010 is the address location. Understand it now? A is a variable, its location is 1010, and the data in this location is what there, 50. Fine. Next one is, when compiler compiles this in a section into star p, when a compiler compiles this in a section into star p, so p is a variable, it has some memory allocation. How much memory will be provided here? How much memory is required to store address locations? That much memory will be allocated. That's okay, fine. When a compiler compiles this in a section, first ampersand a will be calculated. That is what their address location. That address location is assigned to what variable? P variable. Now the p variable value is what there here we can understand, 1010. It means that p variable is referring this address location. P variable is referring what there, this particular location. So physically it is pointing this a variable address. The p variable is referring what there, a variable. That's it. Now this is what exactly the meaning of what their pointers and its memory allocation. Now tell me, who is performing this entire work now? Who is performing this total work here? Compiler. Compiler is performing that entire work inside the C and the C++ programs. The same point here I'm telling to you. In general, pointer variables are recognized and initialized by the compiler at the compilation time. In general, pointer variables are recognized and initialized by the compiler at the compilation time. Now that compilation time only compiler can perform this pointer variables recognition and initialization. Is that, are you getting it or not? Okay, fine. Next one is what? After completion of this pointer variable and its recognition and all, after that I have a question, directly question here. After understanding this pointer variable basic information also, here my question is what? Why pointer variables? Why pointer variables are not available, not existed, or not required in a Java? At the same time, the question is what there? Why are pointer variables not existed, not required in Java? At the same time, other question is what there? Why are these pointer variables required in C and C++? Why are pointer variables are not required in Java? Why are pointer variables required in C and C++? That internally that question is also be coming there. Correct? Indirectly what I am telling there, why pointer variables required in Java, C and C++, why pointer variables are not required in Java? That questions can be have to understand. Now I'm going to give some answers to you. Try to observe carefully. The very first answer, all of you understand it now. Now tell me this line now. Please recognize this line here. What is the point here I said to you? In general, pointer variables are recognized and initialized by the compiler at the time of compilation. That means, now tell me, for the pointer variables, who is providing memory allocation? Compiler. Compiler has provided memory allocation. At what time? Compilation time. If memory allocation is provided at compilation time, automatically that memory allocation is what? Static memory allocation. Am I right or not? If the compiler is providing memory allocation for the pointer variables, in the sense static memory allocation is going on or not? Now here the point is what is the first point here I'm telling there? Pointer variables required static memory allocation. Pointer variables required what there? Static memory allocation. But Java is following dynamic memory allocation. Come on guys, the very first point here I'm telling there, pointer variables required static memory allocation, but Java is following what there? Dynamic memory allocation. Now observe carefully, what's the point here I'm telling there now? Observe carefully. Pointer variables require static memory allocation, but Java is following what their dynamic memory allocation. Because of this reason, pointers are not suitable inside what their Java programming language completely. Now, this is one point here. Next one is, apart from this, another point like what I'm telling to you, pointer variables. Because of this first point, the second point I'm providing there. What is this first point here? Pointer variables require static memory allocation, means that pointer variables are supported by the static programming languages. Pointer variables are supported by which programming languages? No, static programming languages. But Java is a dynamic programming language. Is it? Java is what there? A dynamic programming language. Pointer variables are supported by the static programming languages, but Java is a dynamic programming language. Because of this reason, pointer variables are not suitable in the case of Java programming language. That is one point here. Understand it now. Point number 3. Put more concentration here. Pointer variables are very much suitable. Pointer variables are very much suitable in the platform dependent programming languages. Pointer variables are very much suitable in the platform dependent programming languages. Everybody understand it clearly. But Java is what there? But Java is a platform independent programming language or not? But Java is a platform independent programming language or not? Right, sir. So because of this reason also we can conclude that pointers are not suitable in the case of Java. Pointers are very much suitable in platform dependent programming languages, but Java is what their platform independent programming language. So pointers are not suitable. Next one is, apart from this, point number 4. All of you observe carefully. Point number 4, what I'm telling to you, pointer variables is a bit confusion oriented programming feature. Sure. Why I'm telling the pointers is a bit confusion oriented programming feature, no? In the case of pointers, single level pointers are available, multi-level pointers are available. What is the meaning of single level pointer? No, directly pointer is referring data. Pointer is referring data. That is single level pointer. But multi-level pointers are available. One pointer is referring another pointer. Another pointer is referring some other pointer. Some other pointer is referring what there? Some other. Got my point or not? So like this, multiple levels are available about these pointers. Everybody observe carefully. So when we come for this multi-level pointers now, up to 1 level, 2 level, 3 level, okay, we can trace it. Which pointer is referring which pointer and which pointer is referring which data, that we can trace it up to 2 level or 3 level. For example, If the multi-level pointers is like what, there 10th level, 12th level, 15th level, definitely we are able to get confusion. Which point is referring which pointer like this? We are able to get some confusion now. Are you forget my point or not? So because of this reason, what's the point here I'm telling there? Pointer variables is a bit confusion oriented feature. It's a bit confusion oriented feature. Get my point or not? But what about the Java? Java is a simple programming language. But Java is a simple programming language. It must not allow the confusion oriented features. It must not allow the confusion oriented features. This is another point here we can understand. Right, sir. Pointer variables are a bit confusion oriented programming feature, but Java is a simple programming language. It must not allow the confusion oriented features. That's okay, fine. This is one point. Next one is after this. Another point here, observe carefully. Pointers will provide lesser security. Pointers will reduce security to the applications. Pointers will reduce security to the applications. How, sir? How can you say that pointers are able to reduce security to the applications? No. Pointer variables are representing address of the data or not? If we catch the pointer variable value, address of the data, we are able to get it or not? Once we are getting address of the data, we can manipulate the data easily. So it's very easy to catch the data and to modify the data. So security problems will come with these pointers. That's why pointers will reduce security to the applications. But Java is a very good secure programming language. Java is a very good secure programming language. It must provide very good security for the applications data. It must provide very good security for the applications data. Because of these many reasons, we can conclude that pointers are not suitable in the case of Java, but pointers are required in the case of what there C and C++. Come again here. What exactly the question here I've asked there? Why are pointer variables not required in Java? Question is what? This is a question. Pointer variables require static memory allocation, but Java is following dynamic memory allocation. Whereas in C and C++, which memory allocation is going on? Static memory allocation is going on. So pointers are suitable in C and C++, but pointers are not suitable in Java. Listen carefully. Pointer variables are supported by the static programming languages. C and C++ are what? Static programming languages where pointers are suitable. But Java is what? Their dynamic programming language. Pointers are not suitable in the Java dynamic programming languages. Pointer variables are very much suitable in the platform dependent programming languages. Now tell me, C and C++ are what? Platform dependent, where pointers are suitable. Pointers are required. But Java is what there? A platform independent programming language. Pointer variables are a bit confusion oriented programming feature. C and C++ are bit confusion oriented programming language only. They are not simple programming languages. But Java is what there? A simple programming language. It must not allow the confusion oriented features. Next one is pointers will reduce security to the applications. Pointer variables will reduce security to the application. C and C++ are less secure programming languages only when compared with Java. But Java is a very good secure programming language. It must provide very good security for the applications data. That's it. Now this is exactly the meaning of like what there pointers and it's the related content here we are understanding clearly. Got it or not? Then immediately observe carefully. Even if we give this much of answer in the case of C and C++, but interviewer will ask one more question now. What about the question that interviewers are going to ask there? One more question. Observe carefully. In the case of C and C++, a variable is referring a block of memory. So that variable is what? Pointer variable. Am I right? In C and C++, a variable is able to refer a block of memory. That's why we have taken this variable is what there? A pointer variable. Understand it now. Similarly, all of you observe carefully. Similarly, in in the case of Java, when we create a class with some members, when we create an object for the class, a small a is equal to new a. When we create an object for the class, a small a is equal to new a. Automatically, an object will be created. Object is nothing but memory block only, not any other one. Object is what there? Memory block only. This object is referred by a variable. What variable here? A variable. Okay. Same thing is going on in the case of Java also. Now here the question is what? In the C and C++, a variable is referring block of memory. That's why this variable is pointer variable. Similarly, in the case of Java, when we create an object where a variable is referring a block of memory, so why don't we call it as a pointer variable? How can we say that pointer variables are not available in Java? Got my point or not? In the case of Java, when we create an object, object is nothing but block of memory that is referred by a variable A. So here also a variable is referring block of memory. So how can you say that pointers are not available in Java? And why don't we call that A variable is what there? A pointer variable. This is a question here. In the case of Java, a variable which is referring this object is not a pointer variable, that is called as what there? A reference variable. In Java, that variable is called as what there? A reference variable. But in the case of C and C++, this variable is called as what there? Pointer variable. Now, actually, the question is what there? Interview question is what there? What are the differences between pointer variables and reference variables? What are the differences between pointer variables and reference variables? This is a question actually. Okay, but if you want to answer for this particular question, here we need to understand clearly how pointer variable is created, how reference variable is created. If you understand it, then we can compare both the variables. As of now, we are aware already how pointer variable is created. Pointer variable is able to refer a block of memory by storing address of this particular data. Pointer variable is able to store directly address of this data. So we can understand it. Pointer variable is referring what there? This block of memory. Understand this point now. Similarly, how reference variable is created, if you know that, then we can compare with the pointer variable. After that, we can decide whether both are same or different. After that, we are going to understand. Get my point or not? So first of all, we need to understand how reference variable will be created. That's it. I'll give some clarity. Try to understand these points now. For example, I want to take this is like what there a class A. Inside this class A, we are having number of elements. Some content is available inside this class here. Some elements are available. Okay. After this, now here we are going to use a small a is equal to new a object here we are creating. Now tell me, in Java, who is executing our Java programs now? Come on guys, execution could be done by one component. What is that component there? Already, yesterday we discussed about it and today also I given that information there. Java programs are executed by whom? JVM. JVM will execute the Java programs, not any other component. Only JVM will execute our Java programs. Now tell me, in Java we are going to use one type of memory. In Java we are using one type of memory. The type of memory is heap memory. In Java we are using one type of memory. That memory is what there? Heap memory. To control this total heap memory, one person is assigned. To control this total heap memory, one person is assigned. All right, who is this person actually? That person is heap manager. To control this total memory, one person is assigned. That person is what? Heap manager. Heap manager. Okay, now observe carefully. When JVM execute this particular instruction, when JVM execute this particular instruction, what is that intersection here? A small j is equal to new a constructor, especially new keyword. Immediately, JVM will request to the heap manager about to create an object for class A. Immediately, JVM will ask the heap manager about to create an object. Right. When JVM is asking to the heap manager about to create an object, then here what we have to do there? When JVM is asking to the heap manager about to create an object, immediately heap manager will search for a block of memory in the heap memory. Thus, when block of memory is identified, it will create an object for the class A. For the requirement of the JVM, object will be created inside the heap memory. Now, this is exactly the meaning of like what their object. This is called as like what their object. Object is created here. Clear. When an object is created here, when the object is created, now first of all, tell me one point here. In memory, how many objects are going to be created? In Java applications, how many objects are going to be created? Is that only one object or more than one object? Definitely more than one object here we are able to create. It is not exactly one object. More than one object here we are able to create. Understand it clearly. Alright, sir. It's like what there, more than one object here we created. When we create this more than one object, but for each and every object we need to have some identity or not? When we create more than one object, then for each and every object we need to provide some identity or not? Alright, here that identity is provided by heap manager for each and every object in the form of an integer value. That identity is called hash code of the object. Identity is created for each and every object in the form of an integer variable, integer value. That integer value as an identity for each and every object is called hash code of the object. What is this identity? Hash code of the object. When hash code value is created, then immediately heap manager will take this hash code value. Heap manager will take this hash code value. Then after this, heap manager will send this hash code value to heap manager will send this hash code value to JVM. Heap manager will send this hash code value to JVM. Now the hash code value is what there? 1, 2, 3, 4, 5. Now here what JVM is doing now, JVM will take this hash code value. JVM will convert this hash code value into hexadecimal form. JVM will convert the hash code value to what there? Hexadecimal form. Alright. Hexadecimal form of hash code will be created here. Hexadecimal form of hash code is called reference value of the object. Hexadecimal form of the hash code is called as what there? A reference value of the object, that we are getting clearly. What is the reference value of the object? Hexadecimal form of hash code. What is that hash code now? Hash code is an unique identity provided by heap manager for each and every object inside the heap memory. Alright, sir. When reference value is created, JVM will assign that reference value to a variable. That variable is called a reference variable. This variable is called as what there? A reference variable. Understand my point here now? When a reference value is generated, that reference value will be assigned to a variable. That variable is called as what there? A reference variable. Understand the point clearly? Now here the point is what? What is a reference variable? A reference variable is a variable which stores the reference value of the object. What is the reference value of the object? A reference value is a hexadecimal form of the hash code. What is a hash code? Hash code is a unique identity provided to each and every object in the form of an integer value. Now, you only tell me, a reference variable is able to refer a block of memory by storing object reference value. Object reference value is not address location. Hash code is not address location. So reference variable is not at all using any address location to refer a block of memory. It uses reference value. Reference value is a hexadecimal form of hash code. Hash code is an unique identity provided by heap manager. But in the case of C and C++, pointer variable is able to refer a block of memory by storing what? Address location. But in the case of Java, a reference variable is able to refer a block of memory, but not by storing address location, by storing what? The reference value of the object. The reference value of the object is not address location. Hash code is not address location there. So both are different or not? Pointer variables and reference variables both are different or not? So because of this reason only we can conclude that pointer variables are not at all available, not existed in the case of what? There Java. Pointer variables are available inside what? There C and C++ only. This is what exactly the conversation, what exactly the point here we have to understand. Now let me check this point here. The very first point here, what I am telling to you, observe carefully. Pointer variables exist in a C and C++, whereas reference variables exist in Java. Next one is after that. Pointer variables are recognized and initialized at the time of compilation, whereas reference variables are recognized and initialized at a runtime. Point number 3. Now this is our required point here. Pointer variables are able to refer a block of memory by storing address locations of the data. Pointer variables are able to refer a block of memory by storing address locations of the data. Right, but reference variables are able to refer a block of memory. Reference variables are able to refer a block of memory by storing refer a block of memory, that is an object, memory in the sense object, by storing object reference value. Reference variables are able to refer a block of memory, that is an object, by storing object reference value. Where what is the reference value actually? What is the meaning of this reference value? What's your understanding about reference value? Where the object reference value is the hexadecimal form of the hash code. Okay, where object reference value is the hexadecimal form of the hash code. Where what is this hash code actually? What is this hash code now? Where hash code is an unique identity. Hash code is an unique identity for each and every object provided by the heap manager in the form of an integer value. Provided by the heap manager in the form of what? There an integer value. Come again. Reference variables are able to refer a block of memory, that is an object, by storing object reference value. Where the object reference value is the hexadecimal form of the hash code, where hash code is an unique identity for each and every object provided by heap manager in the form of an integer value. Got it or not? This entire content here I provided here. So overall, what exactly the differences between pointer variable and reference variable? If you observe this, pointer variables exist in C and C++, whereas reference variables exist in Java. Pointer variables are recognized and initialized at the time of compilation. Reference variables are recognized and initialized at the runtime. Pointer variables are able to refer to a block of memory by storing address locations of the data, but reference variables are able to refer a block of memory, that is an object, by storing object reference value, where the object reference value is a hexadecimal form of the hash code, where hash code is an unique identity for each and every object provided by the heap manager in the form of an integer value. This is exactly the meaning of like what there pointer variable and reference variable. Now this diagram as is I'm providing there in the document so that we can understand this point clearly. We are able to understand this point clearly. 1 minute. Right, sir. It's okay. The total diagram also here I provided here. Just at least if we refer this diagram, easily we can understand how pointers are available, how pointer variables are going to be existed in our content that we understood clearly. Leave this point here. After this, after completion of this particular content here, another thing is like what I'm telling to you after completion of this difference is completed. Overall, this pointers and its related point is completed clearly. You can understand it now. Next one is one very small difference is available that I want to complete now. Try to understand it. Now almost all what we completed here, 4 points can be completed. Fifth point here I'm telling to you, observe carefully. Fifth point, destructors are required in a C++, but destructors are not required or else maybe. Instead of this point, I want to take a simple point here. Understand it now. Why? Because within 10 minutes I'll finish this point here. All right. C and C++ are following both call by value and call by reference parameter passing mechanism. Yes, sir. C and C++ are following both call by value and call by parameter passing mechanism, but Java is following only call by value parameter passing mechanism. Nothing, sir. Point is very simple. Understand it now. Before going to understand C, C++ and Java following call by value, call by reference, whatever it may be. But first of all, what is call by value? What is call by reference? After that, we are going to understand C and C++ are following what and Java is following what. Easily we are able to understand it now. First of all, listen carefully. What is this call by value? When we are able to say this call by value now. Observe carefully. In all the programming languages, observe carefully. In all the programming languages, if we pass primitive data as a parameters to the functions or methods, what data? Primitive data. What is this primitive data actually? Byte to short to int to long, float to double, boolean, char. Yes, sir. Got my point or not? This type of data is what their boolean data, integer, float. This type of data is called as what their primitive data. If we pass primitive data as a parameters to the functions or methods, then the parameter passing mechanism is call by value parameter passing mechanism. Simple punch. If we pass primitive data, byte to short to int to long, float, double, boolean, char as a parameters to the methods, then that parameter passing mechanism is what their call by value. Right, sir? Now this is quite common in every programming language. In C, C++, Java, this call by value is available. No need to think about it. But what about this call by reference parameter passing mechanism? In any programming language, if we pass address locations as a parameters to the methods or functions, what we are passing there? Address locations. And before that, one point here I'm telling there, in a C, C++ and Java, call by value is possible. In C, C++ and Java, call by value is possible. Call by value is existed. We can understand it now. Now come for this. In any programming language, if we pass address locations as parameters to the methods or functions, address locations directly. Then that parameter passing mechanism is called called by a reference parameter passing mechanism. In any programming language, if you pass address locations as parameters to the methods or functions, then the parameter passing mechanism, then the parameter passing mechanism is called by reference parameter passing mechanism. Now here come for this point here. In C and C++, if you pass pointer variables as parameters to the methods, then the parameter passing mechanism is called by reference. Why? Because pointer variables are representing what? Address location. Passing pointer variable as parameter to the method in the sense passing address location only directly. So got my point or not? Pointer variable is nothing but what there? Address location. If you pass pointer variable as a parameter to the method, automatically we are passing what there? Address location as parameter to the method only. Right, sir. Understand my point here? In right, sir. In C and C++, if you pass pointer variables as parameters to the methods, then the parameter passing mechanism is called by a reference. Why? Because in C and C++, pointer variables are representing address locations. Pointer variables are representing what? Their address locations. Because of that reason, call by reference is possible in the case of like what there? C and C++. But in the case of Java, for pointer variables, what is the equivalent concept? No? For the pointer variables, what is the equivalent concept here? Reference variables. What reference variables are able to store now? Tell me. Object reference value. Reference value is what there? Hexadecimal form of hash code. Hash code is what there? An integer value. Is not address location. Please remember this. So because of the reason, what is the point here I'm telling to you? In Java, if you pass object reference variable as parameter to the methods, then the parameter passing mechanism is called by value only. Even though if you pass reference variable as parameter to the methods, but still the parameter passing mechanism is what there? Called by value only, but not called by reference. Why, sir? Why it is the case? No, why it is not called by reference? Why? Because observe carefully. Why? Because in Java, object reference variable is able to manage object reference value. Is able to store what their object reference value, where the object reference value is the hexadecimal form of the hash code, where the hash code hexadecimal form of hash code, where the hash code is an integer value, is an unique identity provided by the heap manager in the form of an integer value. Right, sir. A hash code is an unique identity provided by the heap manager in the form of an integer value for each and every object. So, even though if you pass reference variable as parameter to the methods, then the parameter passing mechanism is what there? Called by value only, not called by reference. Due to these reasons, what is the conclusion here? We are able to say that C and C++ are following both the call by value and call by reference parameter passing mechanism, but Java is following only what there? Call by value parameter passing mechanism. Yes, sir, got or not? There is no chance of getting call by reference in the case of Java. In the case of C and C++ only, call by reference is available. Yes, sir, got it or not? Right, sir. So these are all the points here we are understanding clearly. That's okay, fine. Right, I want to stop this session today, then tomorrow I'll continue the content here. But before completing this class here today, a small information to you. Listen carefully. So every day I'm taking the classes for you on 3 to 4:30. These 3 to 4:30 classes are going to be continued maybe one more week of time. Understand it here. Within week of time, this introduction part is going to be completed. But parallelly, tomorrow onwards, along with the 3 to 4:30 class, you have to attend it 4:30 to 6 also. As I said to you already number of times, I want to take your class at 4:30 to 6. Okay, so these 3 to 4:30 classes are continuation next 1 week of time. But tomorrow onwards, along with this 3 to 4:30, you must attend for what there 4:30 to 6 also. Tomorrow at 4:30 to 6, I will show how to prepare first application, how to download Java software, how to install it, what are the setups we require, this kind of preparing first program, compiling first program, execution of the first program. The points I'm going to discuss with you on tomorrow onwards. So without failure, try to attend for it. Tomorrow onward, 2 slots, 3 to 4:30. Next one is what there, 4:30 to 6. But 3 to 4:30 classes are going to be completed in a week of time. After that, you have to come at only what time here? 4:30 to 6 only. No need to come at what there? 3 to 4:30. Please remember this point here. Okay. Right, sir. Thank you. Thanks a lot. We'll meet on tomorrow at 3 o'clock.